uh, make a generative melody and sequence in Tone.js. So let's see, let's go to Chrome and I want to, so I'm going to open Replit and make a new project, but then I also want to just talk a little bit about how this concept kind of fits into the larger sort of programming world. So I'm going to go to my changes. Replit's been making a lot of changes to their interface recently. So let's see, here's my folder. Okay. Um, oh, I made this triplets thing, Gal, that I think I didn't send to you, but I'll send it to you later. I figured out the triplets thing. It's probably not exactly what you want, but I think it's the easiest way to do it. But anyway, we're gonna start with the tone sequencer, but we're gonna fork it and make some changes here. And we're actually going to make a good number of changes to this. So we're going to be reusing some of the code, but we're going to be changing a bunch of stuff as well. So I'm going to fork this project, and I'm going to call this Tone Generative Melody, and click fork. So now I'll have a new copy to work on, and I'll put a link to this in our voice chat. So you guys can look at the code there and fork that uh, for your own project. But yeah, we are going to make a lot of changes here. I'm going to go over to script.js, and let's also change my font size to huge so we can see it better, and go back here. Okay, and then I'm going to close this bit, and let's open the preview in a new tab so we can see the console. Um, and let's change up our comment here. So I'm going to leave these links in here because they're still useful, but in this one we're doing a generative melody. And so we're going to make a bunch of changes here, but I'll go over those in a minute. Let's get rid of, I'm going to leave this here because it is nice to see it refresh and see if there's any errors without going to the other window, but I'm just going to make it a little bit smaller. Okay, I think that should be good. Okay, so before we get into actually writing some code, let's talk about what we're going to be doing, which is writing a very simple algorithm that will generate a melody for us. And what I want to do is kind of talk about what we're writing and how it differs from different types of algorithms that you might be familiar with. So uh, we are going to write an algorithm, which should be kind of exciting. You guys probably hear the term algorithm all the time. So let's put algorithm up here. And what an algorithm is basically just a computer program that makes a series of decisions about based on some kind of input and then has some kind of output. So people refer to lots and lots of different applications as using an algorithm. The place where you're probably most familiar with hearing algorithm is, especially recently, is with social media. People talk a lot about like the TikTok algorithm or the Facebook algorithm or things like that, and how that kind of like affects the way that we see content on those platforms. But pretty much every application that we use uses an algorithm of some type. A good example would be Google Maps. Like Google Maps has a very good algorithm for determining the fastest way for you to get from one place to another. And a lot of us probably use that almost every day. I certainly use it pretty frequently, whether, I'm taking the train somewhere or walking somewhere. Even a lot of the time when I know how to get somewhere, I'll still look at Google Maps to, confirm that I'm going in the right direction or something like that. So we use these things all the time. And so it's good to kind of understand how they work and what they do. And they are kind of simple on a basic level. And the other thing that I want to do is differentiate an algorithm from a different type of programming concept that you probably hear a lot about more recently, which is like artificial intelligence or specifically machine learning. So I'll put that down here. So machine learning is like the specific type of artificial intelligence that I want to differentiate down here. But artificial intelligence is kind of like a larger blanket term that incorporates machine learning, might incorporate algorithm depending on how you're talking about it, but is more kind of like widely used. Um, so let's talk about algorithm first. So what we're trying to do is generate a melody. And usually when we are using an algorithm to do something, it's based on rules. Okay, so rules that we create. So rules that a person creates by analyzing something. So let's say we have, a melody and we kind of like make decisions. So let's say our melody kind of looks like this. There's some notes, there might be a rest, there might be some more notes, whatever our little melody is. We might, as a person, we're kind of like a human being over here. We might look at this and say, here are the rules. So rule number one is you have to start with a note. And rule number two is that that note has to have another note after it. And rule number three is if you have two notes, then you have to have a rest. And rule number four is if you have a rest, then you have to have another note. And then you might have other rules like this note has to be, the same as either this note or this note. You can start to make some kind of decisions, based on what you think will make a good melody. But ultimately, with an algorithm, there's like a person who is kind of analyzing whatever it is that we're trying to create and coming up with a set of rules, and the algorithm goes through those rules, and then the end result is whatever this new melody is, which is going to be different. It's not going to be exactly the same. I broke the second rule. Let's put a note right here. uh, it's not going to be exactly the same, but it'll have the same qualities because it's going to follow the same rules as the media that we analyzed. And we can do that with one melody. We could do that with 100 melodies. It's kind of up to us in terms of what those inputs are. So with an algorithm, there's usually a person who's making these choices about, what these rules are. So the person is looking at what they want to do, and then they're coming up with a set of rules, and then using the computer to generate something based on those rules. So that's what we're going to be doing today. With machine learning, what happens is a little bit different. There are a lot of similarities, but what happens generally with machine learning is you might have one melody that we want to analyze, but that wouldn't really work very well. With machine learning, what we actually need is like maybe 1,000 or 1,000,000 of these. So let's say we have 1,000,000 different melodies. And then that's what we actually put into our algorithm, which, there's different versions of it, obviously, but instead of us making rules based on our interpretation of some data, some music, we actually just feed all of the music that we have ever heard or that we know about or that we want as a subset of music into an algorithm that is just kind of like looking at the qualities of that music, and then it comes up with its own rules. So it actually inputs its own rules and it follows those rules to create a melody. So they're not 100% different.
Is
Uh,
that how YouTube recommendations work?
Yeah, YouTube recommendations are a combination of these two things. So YouTube, like I don't know what their exact algorithm is. You can make some like kind of guesses based on what you see as the results, but they're taking a ton of different inputs because they have millions and millions of different users, and they're using a computer to analyze those inputs and then make rules for what to show people next. So yeah, the big platforms are using something more similar to than a regular algorithm. So there are similarities, like the code will look very similar in terms of a basic algorithm versus machine learning. But that's kind of the main difference is like we're coming up with the rules versus the computer coming up with the rules. That's very like simplified, but that's just like an easy way to kind of think about the differences. Um, so yeah, we're gonna write our own algorithm, and what I'll say is that I'm gonna come up with some rules for how to generate a melody, but those rules are not the only rules that could exist. You guys can come up with your own rules, and that's how you will be able to create your own type of melody. So let's get into it. We'll start actually writing some code, and let me know if you guys have other questions. But I'm gonna go back over here, and so I'm gonna change things up a little bit. I'm gonna keep using some of the stuff that we've used, but I'm not gonna be using like as much of the kind of random stuff that we have down here, like random note, random chord, all this other stuff. Um, I'll leave it there because it doesn't hurt to have it there, but I'm probably going to skip these functions. So instead of just generating random stuff, what we're going to do is we are going to use some randomness, so there's some amount of unpredictability, but we're going to be coming up with more specific rules to play the sounds that we want to play. And then I'm going to take out the chords for now because it's just going to be easier to focus on notes. So I'm just gonna get rid of this stuff. We made chords on Monday, and I do want to use tonal for at least one thing, but I'm not going to use chords at least for now. You could reintroduce chords in here if you want to. Uh, and actually, I'm not going to use durations either. I'm just going to keep this super simple. So we're just going to have a note in our sequence and we'll just use one default duration for everything. Um, so I'll change this duration to default duration. Okay, we're still going to have a sequence, so we're going to leave that, and we're going to generate the sequence, but we're going to use a different bit here, so I'm just going to delete. Actually, let's go from, okay, so this is the update that I made to the play loop. Uh, I think this, or this should just be note. Okay, so I think that's fine, and then we'll just go from the top. Um, okay, so we still need a synth. That's good. We still need a loop. I'm gonna get rid of the sequence num. We don't need this here. We still need a sequence and an index for our sequence, and we still need a display note. Uh, we could use the octaves. I'm just gonna get rid of this actually. I'm going to try to keep things simpler here because as we saw a little bit on Monday, music theory gets pretty complex. And one of the things that's going to make it a little bit easier for us to get started with this new topic is just to try to keep things kind of simple. Um, so then I'm going to set a default duration here. So I'm going to say default duration. So we can change this if we want, but I'm just going to set this as an eighth note. And so my loop will play every eighth note, uh, and um, we'll just base everything on that. If we want to change it later, we can always update it later. And then this stuff, I'm going to do this inside of setup, so I'm just going to get rid of this. Okay, so this is everything I think I need to have global, because my synth is going to be set up in setup, and then it's going to run in the loop. Same thing with my tone loop. Same thing with my sequence and my index and my display note. The default duration I'm not using anywhere else, but we can leave it there for now. So just going to simplify some stuff up here. And then let's just delete all of this stuff and kind of start our sequence from scratch. And this is where we're going to write our uh, melody generating algorithm. So for now, I'm just going to say console.log, and let's take a look at what our sequence looks like. And it's not going to look like anything, but we're going to add to it. So now if I run this code, uh, so it's really small over here, but you can see it says sequence array, and it's just an empty array. So right now we have nothing. Let me see if I can change the font size on here. That's the display size. No, it won't let me change the font size. Okay, that's fine. Um, so it's kind of small, but you can see here, it just says sequence array and it's an empty array. And if we reload our page over here, we're gonna see the same thing. So sequence, and it's just an empty array. We just have a list with nothing in it. And so we're gonna have to make some rules about what to put in it. And we're gonna base this a little bit on music theory. So we're not just gonna have totally random notes bouncing all over the place. Although if you wanted to, you could. Generative music doesn't have to be melodic. If you have an idea for something that doesn't use music theory at all, that's fine. But I'm just going to use a little bit of of the tonal stuff just so we can get a sort of set of notes. So let's start by randomly choosing a key. So we'll get a random key each time. So I'm going to put a comment and say, uh, here's my melody generation algorithm. And so I'm just going to start by getting a key. I'm going to say let, and I'll use the term tonic here, which just refers to the note of the main key. And I'm going to set this to a random note. So we'll have a few choices. So it's not always the same. And so let's just do C, D, or E. So I'm not doing every note that is available, but we're just getting one random note that's either C, D, or E. And you can change this. You can put whatever notes you want in here. And the random here is from P5, so it's just a random. It's going to give us a random value. And instead of giving it numbers, what I'm giving it here is a list. And so in my list, I have the letters representing the notes that I want for the main note of my key. So once we have a tonic, we can get some notes. So for my notes, I'm going to say let notes, and I actually might need my notes to be, hmm, I'm trying to think. I might need my notes to be global. I don't right now, so we might have to change this to global later, but for now, let's just leave this here. So for our notes, we're going to use tonal. So I'm going to say tonal, and we want to use key to get a key. And then I'm going to say major key, and I'm just going to give it the tonic. And so that will give me a set of notes, or that'll give me a key which I can get a set of notes from. So let's log that. So I'm going to say console.log and use the label key, and then say notes here. So we're going to have to do an extra thing to get the actual notes, but let's see what we get from the key first, just as a reminder. So I'll save this and then refresh here. So in our key, we have a scale, and the scale is the notes that go into this key. And so it happened to be C, but it is random. So let's see if we refresh, if we get a different one. Okay, so if our tonic is E, then the notes are going to be different. So our scale is E, F sharp, G sharp, A, B, C sharp, D sharp. So our scale is random based on what our tonic is. So that looks good. Let's go back here. So we don't want the whole object, we just want the scale. Okay, so now if we run this, now we can see our notes down here, C, D, E, F, G, A, B. And then one more thing we need to do with this, because we know, we looked at it last time, that P5, or not P5, sorry, tone is, we have too many JavaScript libraries. Tone is expecting a MIDI note, and a MIDI note is just a note, but it has to have a number after it. So this is going to limit our composition a little bit, but I don't really want to deal with moving between different octaves. So I'm just going to choose an octave for now, and every note will be in that octave. So this is a little bit limiting, but in order for this to be relatively simple at the beginning, we do have to choose some kind of limitations. And if you really want to move between octaves, we could talk about ways to do that later. So now I need to choose an octave. I'm going to say let octave. And I'm going to get a random octave here, so I can choose something random. I'll give the options as 2, 3, or 4, kind of some decent lower and middle octaves. And so then I have to modify my notes so that they have the right octave. So I'm going to say notes, and I'm going to use my map here again. So I'm going to say notes equals notes.map. And I'm going to use map just to add the number of the octave to the end of each one of these notes. So for each note n, we're going to get n plus octave. And that will give us our final set of notes, E4, F sharp 4, G sharp 4, A4, etc., or whatever our key is going to be. So now we have a set of notes to work with that is somewhat random. It's limited, so we've made some choices about what keys we want, and what octaves we want, but we're also using randomness to add some unpredictability. So our algorithm is combining rules and choices that we make with a little bit of randomness so we get some different outcomes. Okay, so now we've got our notes, and so let's start adding our sequence. And so we're going to use a for loop here. There's different ways to do this. You might see something like this done with a recursive function or other structures, but I'm going to use a for loop just so we can keep everything within our setup function. So a couple things that I am going to need to know. I need the notes. I already have my sequence. My sequence is up here because I need to reference it in multiple places. And so I know the sequence exists, but we don't see it here. But then we need a couple other things. We need to know how many notes we want in our melody. And I'm gonna divide my melody into two parts. I'll go over here for a second. So I'm gonna think about a melody as having a phrase, is sort of starting phrase. And when we looked at both of Twinkle Twinkle Little Star and Happy Birthday, we noticed that this was true in both cases, where there's a starting phrase that, might be just kind of like a simple set of notes, something like that. And then that phrase was repeated with some variation. So this I'm going to call a phrase and then a variation. And so that's a rule that I want to apply that basically I want to generate a phrase and then I want to generate, some number of variations, maybe just one, maybe two, maybe three. We could decide or we could let it be randomized. So a variation might take the same melody, but then, move this note down here or something like that. And so we'd hear the similarity in the phrase, but we'd also hear the variation. That's what creates an interesting melody. So I'm going to start with the number of notes I want in a phrase. So I'm going to say let phrase num or phrase, let's call it phrase length. And I'm just going to do 8. I think that's a good default. And then I'm also going to repeat that a number of times. So I'm going to let um, number of phrases, so num phrases. And let's do something random here. Let's say random, and let's say it could be 1, could be 2, could be 3. I guess I could do a random range here. So let's do something between 1 and let's say the most we want is 5. So now I'm going to generate my first phrase. And one thing that's going to help me before I get into my for loop is having a couple of placeholder variables to set as I go. So when I make these different rules, one of the things I'm going to keep in mind is what was the note that we played previously. So the first note just has to be some note, but then after I get past the first note, my next note was going to be something relative to whatever my first note was. So I'm going to want to remember what that note was. So I'm going to use a variable to keep track. So I'm going to have a note variable and I'm going to have a previous note variable, which I'll abbreviate prev note. So that way I can know what the last note was and I can use that to make choices about my next note. Okay, so now I'm going to generate a phrase. And so I'm going to use a for loop to do this. I'm going to say for, I'll say let I equals 0 and I is less than phrase length and I plus plus. And so as I'm generating the phrase, this is where
So
I'm gonna,
what
sorry.
if the previous note is a rest? And then how is it going to be relative exactly?
Well, that's a good example of, that's a rule that we'd have to decide on at the moment. So if a note is a rest, do we want to repeat it? Do we want to, change it or do something else with it? That's an example of a rule that you can come up with to decide how your melody works. But we'll see how to deal with it in code because we will add some rests in here.
Okay.
All right, so we're going to generate a phrase. So we're going to loop through our phrase length, and for every count, 0 through 7, so 8 counts, we're going to add a note. And so let's make a couple rules to start. So if we're at I equals 0, if we're at our first note, then we don't probably want to add a rest. We probably want to add something that we can, a regular note. So let's make that our first rule. We'll say if I, and we'll just say if I triple equals 0. So this means this is our first note. So let's decide what that note will be. So we'll say note equals, and we could say, I want to start on the tonic. We could say I want to start on the fifth and move towards the tonic or something like that. But let's just choose something random. So we can say random, and let's say we're either going to start on 0, which is the first note in our scale. So remember, with lists, 0 index is always the first note. So in our scale over here, the 0 note would be this E4. Um, and so then the other option is, let's say, a fifth, which in JavaScript is actually a 4, because the 4 index is actually the fifth element in our list. So if we're in the first note, let's just assign a random note that's either 0 or 4. And then later, we're going to do some other stuff in here, but for now we have one rule for our first note. And so then once we have everything else, we're going to add that note to our sequence. So we're going to say sequence.push note. And then we're also going to set our previous note to our current note. So we're going to say previous note equals note. So that way, when we loop back around, we'll be able to know what was our previous note. So let's go ahead and run this and see what we get. Uh, so now we have a sequence. Oh, it's just 4. Whoops. Okay, I forgot one step. Okay, so this isn't a note because it's just an index. So let's actually just call this an index. So let's say let index equal random 0, 4, and then we need to use that index to get our note. Sorry, I forgot a step. So
But you already have an index at the global variables. Is that
um,
just gonna override it?
Yeah, that's okay because I'm inside of a for loop, so it won't rewrite this index up here. So it'll just exist inside of here. But we could use a different term here. So let's call this note index. So then we'll use our note index to get a note. So we'll say note equals notes at note index, and that will give us the correct note. So now if we run this code, we can see our sequence is just A4 8 times. So that's not a great melody, but at least we can see the first rule is being followed. And then since we're assigning this note to the previous note, as we go through the rest of our algorithm, since we haven't changed our note, we're just getting the same note over and over and over again. So again, not exciting, but at least our first rule works. And now we can add some more rules. Um, so now let's say else, and this is pretty much for every note after our first note. Let's say we want our last note to be a rest. So we can say else if, and then here we can say I equals, and we can say phrase length -1. So remember that uh, with a for loop, since we start counting at 0, we never actually get to the phrase length, which is 8. Uh, we start counting at 0, so we're always 1 less. So if we want the last note, it's actually phrase length -1. You could change your for loop, like you could say I equals 1 here, and I is less than phrase length, or less than or equal to phrase length. But this is generally, what you're going to see in a program. So this is our last note. And so let's say we always want to end on a rest. That way we get a rest before we start the melody over again. So in this case, I'm just going to say note equals null, and that will be read as a rest by our loop. So let's run this. And so now we get the same note 7 times and then a null at the end. Okay, so our next rule works. So we have a rule for our first note, we have a rule for our last note, and then let's add some rules for every other note. So I'll say else here, and we'll add rules for the rest of our notes. So here we might want to do different things. I'm going to do something that's pretty specific. So you may choose to do something else. You could just have like random notes. But what I want to do is I want to go either one up or one down. One of the things I noticed with um, Twinkle Twinkle Little Star and Happy Birthday is that most notes tend to either just be one note up or one note down. And so I want to recreate that. And so I'm going to make a choice, and I'm going to say let choice, or let's say let next. And I'm going to say let next is going to be random. It's either going to be up or down. And so I'm going to use the previous note to decide what the next note is. And so here I'm just randomly going up or down. So if this returns up, I'll go up. If this returns down, I'll go down. So then I'll say if next equals up, then we have to figure out how to go up. So we know the previous note, right? We know what prev note is, but we don't know what the index of that is. So to get the index, what we can do is say let note index equal notes dot index of previous note. And I'll show you what that does real quick. Let's go over, it'll be easier to just do it in the console right here. So let's say I have my notes. So I have notes and it's A, uh, B, whoops, B, C, and D. Let's just say, for example, those are my notes. So if I want to know which note I'm on, let's say I have a note, let's say my previous note is B. If I want to know where B is in my list, I can say notes.index of prev note, and that tells me 1. So A is 0, B is 1, C is 2, and D is 3. So if I want to know where I am in my list, I just use index of and the value that I want to know, and then now I know where I am in my scale, and I can either go up 1 to C or down 1 to A. So I'm going to say note index equals notes.index of prev note plus 1. And one thing I have to be careful here is that I don't go over the number of notes I have. So I can check, I can say if note index equals notes.length minus 1, that means oh, sorry, wait, no, I don't have to do minus 1 here. So if I say note index equals notes.length, that means that I've gone over. Because remember, notes starts counting at 0, and the length is 4. So if my index is 4, there's no fourth note here. There's no 4 index because we start counting at 0. So it's a little confusing, but this will tell me that I've gone past the number of notes I have. If that's the case, what I'm going to do is just go back to the beginning. So I'm going to say note index equals 0, and now I will get my note. So this again is just a choice. It's just a rule that I'm creating for now. You don't really have to do this. You could just do another random note, but I want to specifically go up or down. So now I'm going to say note equals notes at note index, and again, I don't have to change this because I'm just going to push that note onto my sequence. And then I'm going to reset my previous note. So when I go back around, I'll know what the previous note was. Okay, so if I run this code, I should see something that looks a little bit more like a melody. So we have A, B, 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 C, D, D. Okay, so we could actually probably listen to that. So we can already hear that that sounds a little bit more like a real melody than what we've gotten from just adding random notes. So let's add our down, and then we'll add a couple more options. So I can say if next equals down, then we'll do the same thing. We'll get our note index equals notes.index of prev note, except this time I'm going to subtract 1. So I'm going to go the other direction. And then in this case, I have to check if my note goes below 0, that's when the index would be off. So if note index is less than 0, then I'm going to set it to the other side. Again, it could just go back to 0, but let's say note index equals notes dot length minus 1. So that will make sure that we don't go too far in either direction. And now I can say note equals notes at note index. Okay, so now we have C4, D4, E4, F4, and then back to E4, F4, E4. So we're starting to get something that sounds like a real melody. One thing I do want to have in here is the possibility of a repeat or a rest. So let's add those as well. Those are a little bit more simple. So I'm going to collapse these guys, and I'm going to add a couple more options in here. So again, these are just choices that I'm making. You can make different choices with your algorithm. So I want to have a repeat chance or a rest chance. And this means I just repeat the previous note. So that one's really easy. If I say if next, whoops, equals repeat, then note just equals previous note. That's a really simple rule. We're just repeating the previous note. And a lot of melodies repeat the same note, so that will be pretty easy. And then finally, if next equals rest, we're just going to add a null. So we'll say null equals null. And so here, this is where, Gal, what you were talking about before, if we have a null note, we could run into an issue where we're repeating, a rest over and over again. So down here, I might check and say, only set my previous note if the current note is not null. But let's see what results we get from this, and then we can make changes if we want to. So in this melody, I have A, A, rest, rest, C sharp, B, A. So that sounds more like a melody. Let's regenerate it and see what we get this time. So now we have D, E, F, F, null, rest, rest, D. So that's sounding pretty good to me. I don't think I'm going to change anything else here. Um, I do want to add some other phrases though, so it's not quite as repetitive. So I'm going to try to do this relatively quickly because we've already gone through a lot, but I do want to generate more than one phrase. And I'm also going to have to do something in here that I think will be interesting in terms of using functions as well. So we've generated our phrase. So let's generate our phrase variations. So the first part of our algorithm generates the main phrase, and then we generate a few variations. And let's just collapse this whole thing for a second. Oh, whoops. Oh, this node is still inside of my for loop, so let's get out of here. And then we can collapse this. So we're going to generate our phrase variations. And so for this one, we have a number of phrases. And so we're going to use another loop for that. So I'm going to say for let I equals 0, I is less than num phrases. But then we're going to have to loop through our sequence again to figure out what our original phrase was. So we're going to have a nested for loop. So maybe you remember this from MMP 210. It's pretty simple. We're just putting one for loop inside of another. So for the number of phrases we want, we're just going to add to it. And actually, I'm going to start counting here. Let's see. I'm going to start counting at 1 because we already have one phrase. But I guess this could be 1. So yeah, let's start counting at 0. I think that's fine. And then I'm going to say so in a nested for loop, I do have to change the counting variable. So I'm going to say let j equal 0, j is less than, and then the phrase lengths are all the same. So each phrase has the same length, and then j plus plus. So when I'm generating the variations, what I want to look at is what is the note of the main phrase, and then make a choice to either keep that note the same or change it. So let's find out what the note of the main phrase is first. So I'm going to say let phrase note equal sequence at j. And this is going to keep being the same thing because each time we go back through our loop, j is going to start counting through the beginning of our sequence again. So even though we're going to add more notes to our sequence, we're always just going to be reading the first 8 notes of the sequence. So we're going to get the note from our phrase, and then we're just going to decide if we want to do something with it. So if it's a rest, I don't want to change it. I want the rhythm to stay the same. So I'm going to say if phrase note. So this will be false if it's a rest, if it's a null value. So we're only going to change the note if it's something different. Else, we're just going to say note equals phrase note. So any rest will be the same. And then at the end, just like we did before, we're going to have to push the note onto our sequence. So we're going to say sequence.push note. So if the phrase note is null, we're just going to assign it to the phrase note, and then we're going to push it on here. So the other options are just to leave it the same, or to move it up or down, or to do something else. So let's make an option, and I'm just going to copy the exact same thing from my code up here. So I have random up, down, repeat, and I'm just going to take out rest. So it's only going to go up, down, or repeat. So I'm going to copy this next code and paste it in here. And I'm just going to take out rest. Okay, so I'm going to start with the easy part. If next equals repeat, then our note is the same as the phrase note. So that's the easy one. So that one we can get out of the way first.
You have an extra E in repeat.
Thank you. Okay. And so now here's the tricky part. So now I'm going to say if next equals up, well, I'm just going to repeat this same code, right? It's the exact same code as before. Whoops. If next equals up, then we're going to do this whole thing. So I could just copy and paste that code and it would work fine, but that would make my sense of uh, efficiency upset. So what I want to do instead is abstract this as a function. Okay, so we've talked about that a couple times throughout the semester. We've done things that we want to do more than once, and we've turned it into a function so that we can do it more easily. So let's do that. So let's put these functions, and actually I was thinking we would need these to be global, but these don't have to exist anywhere except in setup. So let's just put them directly into setup. So I'm going to say function get note up. So that'll just get the next note up, and function get note down. And so in each one of these cases, we're going to take a previous note and we're going to find the next note either up or down. So we need an argument of where to start. And so most of this code is going to be the same. I'm just going to copy this and paste it into here. So this is get note up. Oops. So here from if next equals up, I'm going to grab this whole thing and copy and then paste it here. And the one thing I have to do that's a little bit different here is once I figure out what note I want, I have to return that note. So instead of saying note equals notes at note index, I'm just going to change this into return. That's going to return this value to wherever the function was called. And I want to format my code, but the format button is missing. So let's just do it like this. I wonder what happened to that format button. They keep changing the layout here. Okay, so that's get note up. And so now we can replace all of this code with get note up and give it the previous note. And so this is going to go up to that function and it's going to figure out the next note for us and then it's going to return the note back to here. So now I can delete this bit and another advantage of this is look how much nicer this code looks. So instead of having all this other crap in here, I'm just saying, what's the next thing I want to do? If it's go up, then we're going to get the note up. And then we go to our next rule. So this one makes our algorithm much, much easier to read. So let's do the same thing here. We're just going to copy this code for get the note down. So I'm going to select this in copy and then move up to my get note down function, paste this in here, and format this up a little bit. And then instead of assigning the note, since we're inside of this function, I need to return this note. And I think this should work. Let's go down here. And so now I just replace this bit with get note down with the prev note. And remember again that you don't have to do it this way. These are the rules that I wanted to create to generate my melody, but if you have different ideas for creating a melody, you can make your own rules. So let's run this and see if it works. So it is working, but we're getting a lot of null values. So let's try it again and see if that is always the case. Yeah, there's a lot of nulls. This one doesn't have quite as many nulls. Oh, that one doesn't have a lot of nulls. Okay, that one has a lot of nulls. Okay, so let's see what happens, and then if we have too many rests, we can fix one of the rules. Anyway, so we have get note up, get note down. So now I'm going to come back down to my phrase variation, and so now I can repeat and I can get a note up. And now this is a lot easier because I don't have to recreate this code. I just say note equals get note up, and in this case, it's the phrase note that we're changing, not the previous note. So now I just say if next equals down, and we're almost done. If next equals down, note is going to be get note down and a phrase note. And there we go. So in my generate phrase variations, I go through the number of phrases I want. For each phrase that I want, I go through the length of the original phrase. I look at what that note is. And then if that note exists, if it's not a rest, I either go up, go down, or repeat the note. And so if I repeat it, I just set it to the same thing. If I go up, I use my get my note up function. If I go down, I use my note down function. And then if nothing else, I just set the note to phrase note, which should be null here, and then I add that to my sequence. And so let's run this and see how it goes. Let's see if we can hear the variations. So let's try it again. So that's pretty cool. Hopefully you can hear that we are hearing the variations between the different phrases. So we have the original phrase, and then we repeat the phrase, changing certain notes. And so it's a little bit limited because all of the variations are based on the same simple set of rules. But if we change even a little bit of how those rules work, we could come up with very different results. So again, this is just one example of how you could do this. You don't necessarily have to have phrase variations. You could have more rules. You could have fewer rules. You could have more randomness or less randomness. There's a lot of different changes that you could make here. You could also introduce chords or, multiple notes. But this is just one basic approach of creating a melody based on a certain set of rules that I came up with to generate new melodies. So I'm going to save this, and I think I will stop here. And let me stop recording.